So we're going to compare two graphs to start to investigate the points of discontinuity. One graph is x squared minus 4x plus 2 over x minus 3, and the other one's x squared minus 4x plus 3 over x minus 3. So from each graph, let's state the points of discontinuity, or sorry, the non-permissible values. Okay, from here? 3, 3. So x cannot equal 3 for both of them. On grid 1, could you guys graph f of x? Okay, so you can use your calculator help. And I'm just going to put the numerator in brackets too, just to be sure. X squared minus 4x plus 2 divided by x minus 3. I did something wrong. Perfect. Now we got it. Thanks, Chris. Alright. So this is our function here. Based on a non-permissible value, I think it's pretty safe to say that we have a vertical asymptote at 3. So on your grid, you want to just plot that. Okay, so vertical asymptote at x equals 3. Now we can sketch the rest of the function. Does it look like there's a horizontal asymptote? No. Just a vertical one. And let's take a look as well at the function. So when we have the degree of the numerator, sorry, I just have to look at the equation again. When we have the degree of the numerator is greater than the degree of the denominator, do we have a horizontal asymptote? So just by looking at the equation that we started with, there shouldn't be a horizontal asymptote. So when you look at the graph, that makes sense. Okay, now let's graph the second function. And I just have to look here because I don't have it on the screen anymore. So we have x squared minus 4x now plus 3. That was the only change. And it's taking on the shape of a straight line. So just looking at this graph, what shape is it taking on? Good, it's linear. So g of x is linear. Does this graph have a vertical asymptote? Okay, we know that it can't equal 3, right? But does it look like there's a line that the graph's going to be approaching? No. There's no vertical asymptote. But there has to be a discontinuity because x can't equal 3. So this is where we're getting into the point of discontinuity. On your calculator, I want you to press zoom and then go to 4 for decimal. And you see there's a little gap in your graph here? When x is 3, there's a little hole. Okay, I'm going to circle that on my graph here, just so that I'm highlighting that there is a hole. There's a point of discontinuity. And where is that existing? At x equals 3. Did everyone get a hole in the graph?
Yeah.
So just to be clear, there is no vertical asymptote, but there is a point of discontinuity, and why? Because we have an MPV of x not equal to 3. Okay, there had to be a discontinuity because you can't divide by 0. So further investigations, we have graph A and graph B. Graph A is just a line, x plus 2. Let's graph that to start. We have a y-intercept at positive 2, and we have a slope of 1 over 1. So if we're just graphing this without our calculator, we're going to rise 1, move to the right 1. Rise 1, move to the right 1. Okay? Or we're going to fall 1 and move to the left 1. Fall 1, move to the left 1. Once we have enough points, we can connect the dots, and we have a straight line. Were there any discontinuities in the graph x plus 2? Do we have any restrictions? No, because we don't have a denominator. So this is just a line, no holes, no vertical asymptotes. Now let's graph x squared plus 3x plus 2 divided by x plus 1, so b of x. Graph it. And I'm still on zoom decimal, so my graph is showing a little hole. And where would that hole be based on the equation? -1. So first things first, let's draw the graph again. I'm just going to draw the exact same line. And then I'm going to put a hole through that graph when x equals -1. You might want to write hole at x equals -1. So what's the difference between graph A and graph B? Yeah, one is a hole, one doesn't. How about the functions? Here to look at the equation. One has a restriction, one doesn't. Okay, so graph B of x has a NPV of x cannot equal -1. So part D, they're telling us to factor B of x. So if we do that, let's see what happens when we simplify it. So x squared plus 3x plus 2 over x plus 1 will equal 2 factors divided by x plus 1. So we need two numbers that multiply to 2 and add to 3, so we get x plus 1 times x plus 2. And now we're seeing that these two factors can cancel out. And what are we left with? The same graph as A, x plus 2. But what do we have to remember that this graph had? A restriction of x cannot equal -1. So although when we look at the function, the expression that's simplified, it looks exactly the same as just a line, we have to remember where it started. And it had a denominator, it had a restriction on that denominator. So it's a line, but we have a hole. In part E, we're going to find the coordinate of that hole. So what you're going to do is you're going to take this restriction, where x equals -1, you're going to plug it into the simplified form of that rational function. Okay, so I'm just going to put part E up here. Okay, B of x, it reduced to x plus 2. We're going to sub in -1 for our x values. And we get +1. Okay, what's another way of saying b of x or p of x? What can we change function notation to? A y. Good. So the point of discontinuity at when x is negative 1 and y is 1. So this whole we can label in the graph, negative 1 and 1. Okay, without graphing this one, we're just going to reduce this function into simplest form. Okay, so it's telling us to express the original function g of x as a line, which pretty much means factor and simplify. So if I were to factor g of x, okay, we have x squared minus 4x plus 3. We can factor that into x minus 3 and x minus 1. We have common factors in the numerator and denominator, so those can be cancelled out. And our function g of x is simplified to just x minus 1, with a domain restriction of
3.
X cannot equal 3. So with these two pieces of information, we can now answer part B. By subbing in the restriction into the simplified function, we can find our point of discontinuity. So we're going to go g of 3 into x minus 1. And so in other words, we get y equals 2. So the POD is equal to 3, 2. Okay, point of discontinuity is at the point 3, 2. Just to summarize the steps on how to find your point of discontinuity, it's just on this next page here. So first step is you want to factor the rational expression. Okay, you simplify that by canceling out common terms. From your simplified expression, you're going to take the non-permissible value and sub it into the simplified function. So just like we did in the previous example. Hey, just note one more time, if you can't see the whole, you're going to have to press zoom decimal. You get a better image. It zooms right into the whole. Alright, you guys have a polynomials unit test on Tuesday. This example is going to basically review a little bit of that. Because what's the first step for finding your point of discontinuity? What's the first step? Look above. Factor. And we have a third degree polynomial that we need to factor. And that's right from the polynomials unit. So let's look at some potential zeros. Of x cubed minus 7x plus 6. Okay, we get that from our constant. So that will be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. You need to sub into the polynomial one of these values and get an outcome of remainder 0. So you can guess and check, or you can plug x cubed minus 7x plus 6 in your calculator, get an x-intercept to start with, and figure out which one we can plug in to do symptomatic division. So, did anyone plug 1 or negative 1 into x cubed minus 7x plus 6? Maybe I'll try 1. Hey, I'm just going to do the guess and check method. So I have 1 cubed minus 7 times 1 plus 6. Yay, got 0. Okay, always start with 1 or negative 1. Once you have that, you can then go into synthetic division. Okay, so 1 is going to go on the side. The coefficients from my numerator will go up top. So I have 1x cubed, 0x squared, negative 7x, and positive 6. Just a reminder, you have to remember about that placeholder. Yeah. Now bring down the 1, multiply it by its side. So 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Negative 7 plus 1 is negative 6. Negative 6 times 1 is negative 6, and we get 0. So exciting. So our quotient that's left over is x squared plus x minus 6. So your numerator right now is equal to x minus 1 from our factor that we know had a remainder of 0. And we have x squared plus x minus 6. They're asking us to factor this in the product of 3 binomial factors. So we just have to break down this quadratic equation a little further. Okay, and we get x plus 3 times x minus 2. Almost free, Bertie. So f of x, if we just look at the entire function that we started with, will be the 3 binomial factors, x minus 1 times x plus 3 over x minus 2. Or sorry, times x minus 2, all over x minus 1. This is the rational function that's fully factored now. But in order to figure out a point of discontinuity, I have to cross out the common factors. And so now my function is equal to x plus 3 times x minus 2, where x cannot equal positive 1. This step here, or this stage, is what we're going to use for part B, figuring out the points of discontinuity. So I'll just write it again. F of x equals x plus 3 times x minus 2, where x cannot equal 1. So to figure out the point of discontinuity, what do I do with that restriction in the simplest form? Slap it in there, yeah. So we have f of 1 equals 1 plus 3 times 1 minus 2. So we get 4 times negative 1 is negative 4. So the point of discontinuity is at 1, negative 4. Thanks, Bernie.
Heads up.
Yeah, we're just doing the bottom.
I really appreciate it. Thank you.
Oh, it's not in there.
Take care. Over here.
Just kidding.
Okay, so we have our point of discontinuity. Part C is asking us for the zeros of the function. So just remember, we simplified this function down to x plus 3 times x minus 2. So these will be where our zeros come from, the simplified factors. So our zeros will be at negative 3, and from the other factor, positive 2. So let's mark those out. Negative 3, positive 2. Now, taking a look at the simplified function, we have x plus 1, or x plus 3 times x minus 2. Binomial times binomial. Let's just do the first step of FOIL. X times x squared. What shape do we have?
Parabola.
Parabola. Perfect. So, is it going to be a positive or negative parabola? Because the coefficient is positive 1. So, arms face up. We can do a general drawing of this. And what do I need to include in my drawing? The circle or the hole, which states our point of discontinuity. So at 1, negative 4, it'll be roughly here. We have a POD at 1, negative 4. Now, if you didn't trust me, you could graph this to verify, but you will get the same graph. Okay, we're going to call it a day.
Yes.
We won't have time to do that third one, so we'll pick that up on Monday.
I was looking so far.